Why do ceramics break from thermal shock? Imagine holding a hot cup of coffee and then pouring cold milk into it. The sudden change in temperature can cause the cup to crack or even shatter. That's similar to what happens with ceramics when they experience rapid temperature shifts. Ceramics are everywhere, from pottery and tiles to high-tech components. But why do they tend to break so easily under these conditions? Let's find out. Ceramics are known for being hard and brittle. Unlike metals that bend or stretch, ceramics tend to crack or break when stressed. When a ceramic object is heated or cooled quickly, different parts of it expand or contract at different rates. Since ceramics conduct heat slowly, the outside heats up faster than the inside or cools down faster than the inside. This uneven temperature change creates internal stresses inside the material. Think of it like pulling on a rubber band unevenly. It can snap. If these internal stresses become too strong, cracks start to form. Once a crack appears, it can grow quickly because ceramics do not have the ability to stop cracks from spreading. This is because they have low fracture toughness, meaning they don't resist crack growth well. The energy from the tension caused by rapid temperature change seeks releases, and in ceramics, that releases often shows up as visible cracks or even complete failure of the object. The chance of cracking depends on several factors. The material's properties, like how much it expands when heated, called the thermal expansion coefficient, matter a lot. Ceramics with low thermal expansion are less likely to crack because they don't change size as much when heated. Thermal conductivity also plays a role. Ceramics that conduct heat better can spread the temperature more evenly, reducing internal stresses. The shape and thickness of the ceramic piece are important too. Thin, smooth, and evenly shaped objects tend to resist cracking better because heat spreads evenly and there are fewer stress points. Some ceramics are designed to resist thermal shock better. For example, cordierite has very low thermal expansion and is used in applications like catalytic converters, where rapid temperature changes happen often. Other ceramics like alumina or zirconia are chosen for their strength and balanced thermal properties. Engineers can improve resistance by tweaking the microstructure, such as adding small pores or fine grains, which can absorb stress or stop cracks from growing. Interestingly, ceramics fired at lower temperatures tend to be more porous. This porosity can sometimes help them survive thermal shock better, even though they are weaker overall. The tiny pores and microcracks act like safety nets, stopping larger cracks from forming. But this makes the ceramic less strong mechanically, so it's a trade-off. Understanding why ceramics break from thermal shock helps us see how material properties, design, and usage all interact. It shows that failure isn't just about the material itself, but also how it's made and how it's used in real life. By studying these failures, engineers can choose the right ceramics and design them better to prevent cracks and breakage. So, in simple terms, ceramics break from thermal shock because rapid temperature changes create internal stresses that the material can't handle, leading to cracks and sometimes total failure. The risk depends on the ceramic's properties, its shape, and how it's used. Knowing this helps us make smarter choices in designing and using ceramic products every day.